Okay, class, so next we're going to talk about complex numbers. Complex numbers, z equals to a plus bi corresponds to the point A, B in a complex plane. I have a graph for you right there. I know it's ugly. I'm so sorry about that. But anyway, as you can see, r is the distance. And you have theta as the angle. Right, so the point AB lies on the terminal side of the angle theta, where theta is graphed in standard position. R is called modulus of Z, and theta is called the argument of Z. All right, so in order for us to find theta, you have to look at the quadrant where A, B lies on. Okay, so I have all the information for you right there. Let's just try a problem. So, for example, the complex number, let's try to write the complex number Z equals 6 plus 4i in trigonometric form. Or you can call it polar form. Okay, all right. So I'm gonna use radian for theta. I just wanna inform you that. Anyway, so for this problem, first let's take a look at the point. So you see right here we have. Well, let's change that. Let's have -6 plus 4i. So if I want to draw that, it's gonna be right here, right? So we have -6, positive 4. Okay. So that's the point, -6, positive 4. So we're looking for that angle. And of course, we're looking for R. This is R. All right. So first of all, let's try to solve for R. R is the square root of a squared plus b squared. So a in this case is -6. So I'm just going to take -6 squared plus b is 4. So b squared. So that's going to give me 36 plus 16. It's going to give me 52. That's for R. If you want, you can use a calculator and try to calculate square root of 52. But for now, I'm just going to leave it like that. I can use a calculator later on. Anyway, let's figure out theta. So theta in this case is going to be tangent of b over a. I know that much for now. Now notice that the point lies on Q2. So let's go back here. You see for Q2 and 3, we have to add pi to it. So I have to add pi to it. Okay, so this one right here, I can just use the calculator for it. So I have b over a. B is 4. A is -6 plus pi. We definitely need to use a calculator for this. Make sure you fix your calculator, degree, radian, all that fun stuff. So of course I have to use approximation here. So I have about 2.553. Let's round it to 2.55. Okay, so in that case, let's just use a calculator and calculate that. It's about 7.21, so 7.2. Okay, so here we go. We can put in the form Z equals R cosine theta plus I sine theta. So what I have right here are 7.2 cosine 2.55 plus I sine 2.55. And if you want to be lazy, you can write this way, cis 2.55. Then we understand it's going to be cosine 2.55 plus I sine 2.55. So that's our final answer. Okay. All right. Now, I want to introduce you to this problem right here. So we're trying to find -2 square root of 3 minus 2i, and I raise to the power of 5. Okay, so this looks horrible because I don't want you to multiply -2 radical 3 minus 2i 5 times. That's just nuts. Okay, so we have something called the Moivre theorems. So this is really easy. Okay, so let's say if z is r cosine theta plus I sine theta, then z to the n power. So it's like I'm taking r cosine theta plus I sine theta, and I take it to the power of n. It's pretty much r to the n power, and we have cosine of n theta plus I sine n theta. Okay, so let's go back to our problem. You can see our z is -2 radical 3 minus 2i to the 5th power. So for our problem, n is 5. Okay, so we try to, I'm sorry, so this is z to the n power. Okay, so we try to find r. Let's find r first. So r, recall r is a squared plus b squared. So in this case, r is the square root of -2 radical 3 squared plus -2 squared. Okay, so if you do the math, -2 squared is 4, 4 times 3, because radical 3 times radical 3 is just 3, right? So 4 times 3 is 12. So I have 12 plus 4, which is 16. Square root of 16, which is 4. Perfect. So r is just 4. Now, we need to compute theta. So how do I compute theta? Tangent. Don't forget tangent. Theta is b over a. Okay, so in this case, what is b? b is -2. A is -2 radical 3. So what I have is 1 over radical 3. Okay, so if you check the unit circle, you will figure it out that z is in Q3, right? And then we have theta is 7 pi over 6. Okay, now I'm ready to plug it in. I'm ready to plug it in. Anyway, let me just write z first. So z is r is 4. Seven pi over 6. Okay, so we take z to the fifth power. It's gonna be 4 to the fifth power. And then you multiply cosine 5 times 7 pi over 6 plus I sine 5 times 7 pi over 6. All right, so I have to use a calculator for this. So 4 to the fifth power. It's going to give me 1024. And then we have cosine of 35 pi over 6 plus I sine 35 pi over 6. Okay, we can definitely find the coterminal angle. In this case is 11 pi over 6. You can subtract 2 pi. You'll get that. Okay. So we check the unit circle. Cosine of 11 pi over 6 going to give you square root of 3 over 2 plus I. Sine of 11 pi over 6 is going to give you negative 1/2. So you can distribute if you want. Okay, so if I distribute, I'm going to end it up with that divided by 2. So it's 512. Radical 3 plus, I'm sorry, it's negative, minus I 512. And that's your final answer. Anyway, we should write I after. There we have it.